All right, let's go ahead and just jump right in. So in this video, we'll dive into cell adaptation. Specifically, we're going to be talking about hyperplasia and hypertrophy. So by the end of this video, you will have a firm understanding in cell adaptation, high-yield examples, clinical relevance, and pathologic manifestations. It's important that you stick around until the end for the practice questions because this will not only test your knowledge, but more importantly, it will solidify your understanding in these concepts. Our videos focus on high yield principles, okay? High yield principles for not only USMLE, but also clinical relevance and disease understanding. While these videos are specifically tailored for students preparing for USMLE, really anyone who's interested in learning more about disease processes in general will gain a lot from these videos. We're going to begin with a fundamental concept, which is homeostasis, okay? Homeostasis refers to the body's ability to maintain a stable environment despite external changes, okay? It's very important you recognize that your body adapts to external changes that it's placed on, okay? So think of this like building a house. This might make it a little bit easier. When you're building a house, you need to adjust and reinforce the structure based on the different stress it faces. So for example, if you lived in a place where, it's common for hurricanes or tornadoes, whatever it might be, hurricanes, earthquakes, if you're going to prepare, you need to strengthen the foundation or add extra walls to keep it intact. Similarly, organs must adapt to stress to maintain their function, okay? So first, when stress on an organ increases, so stress increases, it builds itself stronger through two key mechanisms, all right? So the first mechanism we're going to talk about right now is hypertrophy. So hypertrophy can be imagined as reinforcing the existing walls of a house, okay? So in biologic terms, this means that the individual cells increase in size by synthesizing more proteins and enlarging organelles, ultimately increasing the organ's overall size. So hypertrophy, synthesizing more proteins, okay? It's very important that you understand this. Additionally, hyperplasia could be thought about as adding new rooms to the house. Biologically speaking, this involves an increase in the number of cells, okay? How does this happen? Through proliferation of stem cells, all right? These are very important. You recognize the differences here. This will allow the organ to grow by creating additional structural support. All right, so by understanding these processes, we see how the body smartly adapts to its environment. The body adapts to its environment, all right? Much like a well-built house adjusts to withstand changes in weather, so does our body. It adjusts to the external forces that are placed upon it. To better understand these mechanisms, let's break them down, all right? So we're going to start with hypertrophy, all right? So hypertrophy, cells grow larger by synthesizing more proteins and increase the size of organelles. This process involves gene activation, protein synthesis, and cytoskeletal expansion. Okay? When you think about hypertrophy, I want you to automatically think about gene activation because a lot of the time students forget and don't really fully recognize that when a cell is increasing in size, genes have to be activated in order to allow for more proteins to be made. The genes tell your cells, let's go ahead and create some more proteins. Ultimately, this leads to cytoskeletal expansion, okay, because your cytoskeleton is made of proteins. All right, so an example that we can talk about here is in response to systemic hypertension, cardiac myocytes, the heart cells, they enlarge because they cannot divide. Imagine your heart lifting weights to handle the increased workload, okay? Now we're gonna go ahead and continue to dive into these concepts, but I just want you to get an overall understanding right now. Now, hyperplasia. Stem cells produce new cells, increasing the overall cell count. Increasing overall cell count, all right? Do you see the difference? Producing completely new cells, whereas hypertrophy was just growing in size from cells that already exist. So a common example that often shows up in tests, especially USMLE, is pregnancy, So during pregnancy, the uterus undergoes both hypertrophy, cells enlarge, and hyperplasia, meaning more cells are formed From what? Stem cells. Good job. To accommodate the growing fetus. So when it comes to USMLE, it's very imperative to remember that both these mechanisms, generally speaking, happen together, meaning hypertrophy and hyperplasia oftentimes, most of the time, will occur together. However, there are exceptions. These exceptions yield very common test questions, okay? So we're going to go ahead and talk about some exceptions to this rule, all right? So to begin, permanent tissues. There's three main types of permanent tissues, okay? So not all tissues can undergo hyperplasia, like we just talked about. So the three main types that we need to keep in mind for USMLE is number one, cardiac muscle. Cardiac tissue is composed of myocytes that are differentiated and incapable of dividing, okay? So in response to an increased workload, such as hypertension, the heart is beating faster, cardiac myocytes will enlarge through mechanisms like upregulation of protein synthesis, increased mitochondrial content, and expansion of the cytoskeleton. This hypertrophy compensates for the increased demand, but can eventually lead to pathological changes, which we'll continue to learn more about as we go throughout these sections. Cardiac muscle is permanent, okay, so it can only increase in size. Another really common example that's brought up in tests is the skeletal muscle, okay, so skeletal myocytes also lack the ability to divide. They're relying on hypertrophy to adapt to mechanical stress, such as most commonly, people think about resistance training. When somebody goes and they work out, their muscles increase in size. So this process often occurs via activation of signaling pathways. A common one is mTOR and increased production of contractile proteins. Really don't get too lost in these definitions that I'm telling you right now, as we'll continue to learn more about it. The most important thing that you keep in mind right now is the main types of permanent tissue, okay, because they're commonly tested. The third is going to be the nervous tissue. So neurons are highly differentiated, specialized cells that are terminally differentiated and cannot regenerate. Functional adaptation occurs through synaptic plasticity, such as strengthening synaptic connections or increasing dendritic branching. However, it's very important you understand, in response to injury, glial cells proliferate, a process known as gliosis. Gliosis helps contain damage but does not restore loss of neuron function. Most importantly, the thing you need to remember right now, the three main types of permanent tissue are going to be 1, cardiac, okay, 2, skeletal, 3, nervous. These cells can only go hypertrophy. They're permanent tissues, okay? They cannot undergo hyperplasia. That's the main point right now, all right? So how do we know? Is hyperplasia good or bad? Pathologic hyperplasia. One way I like to think of this is friend or foe. Hyperplasia is often a normal response to increased demand. It can become pathological under certain conditions, okay? Pathologic hyperplasia refers to abnormal cell proliferation that may lead to dysplasia and eventually cancer. So when there's abnormal cells proliferating, we call that dysplasia. Dysplasia can lead to cancer, all right? It's very important to recognize this. So what creates pathological conditions? Well, there's 5 main ones you need to remember. Excess hormones, chronic inflammation, viral infections, increased demand, or excess growth factors, okay? One example that you can think about is endometrial hyperplasia due to unopposed estrogen increases the risk for endometrial cancer. So endometrial hyperplasia due to unopposed estrogen increases the risk for endometrial cancer. However, there are exceptions. Number 1, benign prostatic hyperplasia. This involves hyperplasia of prostate stromal, so the connective tissue of the prostate, and also glandular cells. Remember that BPH, or benign prostatic hyperplasia, does not increase the risk of prostate cancer, okay? Another common example that you'll see is psoriasis. Hyperplasia of the epidermis, your skin, leads to thick, scaly skin plaques. While it is not precancerous, it represents a pathological but not malignant form of hyperplasia, all right? Another commonly tested example is Graves' disease. Graves' disease is a hyperplasia of the thyroid gland. It occurs due to stimulation of thyroid-stimulating hormone receptor antibodies, leading to a thyroid enlargement known as goiter, all right? This condition is not precancerous, as the hyperplasia is functional and not dysplastic. All right. And lastly, another very commonly tested example I'm going to bring up right now is regenerative nodules on cirrhosis. So hyperplasia of hepatocytes, liver cells, in response to chronic liver injury demonstrates the liver's attempt to regenerate. While the nodules themselves are not precancerous, the chronic inflammatory environment of cirrhosis significantly increases the risk of hepatocellular carcinoma. It's mostly important to recognize that the nodules themselves are not precancerous. So these examples that we brought up right here, all right, these are very commonly tested. Don't get too lost in the definitions right now. I'm just trying to plant little seeds in your brain as we're going to continue to talk about these different disease processes. We're just starting with the very basics right now, okay? So some memory aids that we can use, all right? So hyper means over or excessive. Troph means nourishment, so over nourishment, okay? This is indicating an increase in cell size due to excessive functional demand. Now, hyperplasia, hyper meaning over or excessive, plasia, formation or molding. Okay, this is due to an increase in the number of cells due to excessive proliferation, meaning new cells are made, okay, from your stem cells. Now, let's just go ahead and review some of these examples. So, example, skeletal muscle bulking during weightlifting, because it's a skeletal muscle, will only undergo hypertrophy, all right? Skin thickening in psoriasis, however, is due to an increase in epidermal cells known as hyperplasia. Now, permanent tissues, just for an example, cardio, meaning heart, troph, meaning nourishment. So there's heart nourishment. This emphasizes the heart's ability to enlarge under stress by increasing cell size rather than producing new cells. Hypertrophy, all right? An example that's really important to remember, so the heart enlarges in hypertension due to increased workload but does not generate new cells, explaining why hypertrophy dominates. We're going to continue moving forward. So dysplasia right now also means dys, meaning bad, plasis, meaning formation or molding. It's indicating abnormal cell growth that can progress to malignancy. Malignancy meaning cancer. So these growths are bad and they can end up producing cancer. All right. So an example is endometrial hyperplasia, progressing to cancer due to unregulated estrogen. So just to review one more time, the different types of external factors that can bring forth pathological circumstances are 1, excess hormones, like we see right here, excess estrogen, chronic inflammation, viral infection, increased demand, and excess growth factors, all right? So if we want to go through these one more time, excess hormones, what's an example? Endometrial hyperplasia, like we just talked about. Chronic inflammation, like prostatic hyperplasia, meaning that there is a increased viral infections like HPV, human papillomavirus, increased demand, bone marrow hyperplasia, all right? Bone marrow hyperplasia like anemia. Growth factors, excessive growth factors as well. One example you could talk about right here is granulation tissue and wounds. So these are all examples. Again, all I'm trying to do right now is just place seeds in your brain. The biggest thing we're trying to talk about right now is hyperplasia versus hypertrophy, all right? So high yield summary. Let's go through a couple things. Organs adapt to stress through hypertrophy, cell size increases, or hyperplasia, cell number increases. There are permanent tissues, the 3 we talked about today: cardiac muscle, skeletal muscle, and nerves. These can only undergo hypertrophy, all right, because they lack stem cells. They cannot produce new cells. So pathologic hyperplasia can progress to dysplasia, like we talked about, bad growth, which eventually, because it's bad, can lead to cancer. There are exceptions to this case, like benign prostatic hyperplasia, like we talked about, which remains benign. Additional examples like psoriasis, Graves' disease, and regenerative nodules in cirrhosis. These represent pathologic but often non-malignant hyperplasia. So now we're going to go through a couple USMLE style practice questions to see how you're doing. Now when it comes to these USMLE style questions, How would you start the question? Like I will always tell you over and over and over again, I'm always going to advise you to begin the question by reading the end sentence, okay? So we're going to start here with which cellular adaptation is responsible for this finding? So just from reading this last sentence, we can understand that we're looking for a cellular adaptation for some sort of finding, okay? Then what I would do is I would go through each of the different answers that are listed here to understand the different possibilities for the rest of the question. So like we learned today, hyperplasia is the increase in the number of cells. Hypertrophy is the increase in the size of cells. Dysplasia, remember dys is bad, plasia growth, so bad growth, or atrophy. While we didn't talk about this today, atrophy, A means without, trophy, like we learned, what does it mean? Trophy meaning growth, so without growth. Okay, so let's go ahead and look for what cellular adaptation is responsible for this finding. What's the finding? Let's go ahead and find out. So a 50-year-old man with a history of hypertension undergoes an echocardiogram showing left ventricular hypertrophy. From this, I'll give you a few minutes to try to figure out the correct answer, and we'll go to the next. So if you clicked B, hypertrophy, you are correct. So why isn't it not A? So cardiac myocytes are permanent cells, remember, and cannot divide. So hyperplasia does not occur. Why not C? Dysplasia refers to the abnormal and precancerous growth, which is unrelated in this question. Atrophy, we didn't talk about it today, but it is a decrease in cell size or number, the opposite of hypertrophy, because it's hypertension, excessive tension. That's right, B. All right, question 2. I'm going to go ahead and give you a few minutes to see if you can figure this out on your own. If you clicked D or chose D, you are correct. Let's go through these answers real quick. So, which of the following tissues is least capable of undergoing hyperplasia? Okay, why is it not A? The epidermis regenerates through hyperplasia in response to injury. Okay, so it's not A. B, the liver has regenerative capacity and undergoes hyperplasia after damage. Okay, so we know it's not the liver. The uterus also undergoes both hypertrophy and hyperplasia during pregnancy. So we would know that skeletal muscle is the correct answer. Now, lastly, I'm going to go ahead and give you a few minutes on this question, and we can go ahead and review it together. Okay, so if you clicked C, BPH involves hyperplasia of stromal and glandular cells. Okay, so a 65-year-old male presents with difficulty urinating. Imaging shows an enlarged prostate, and biopsy confirms benign prostatic hyperplasia, or BPH. Which of the following is true? C, BPH involves hyperplasia of stromal and glandular cells like we learned today. Why is it not A? BPH does not increase the risk of prostate cancer, okay? It's very important you remember this. B, dysplasia is a precancerous and not seen in BPH, okay? And D, why is it not D? BPH is primarily driven by DHT, not estrogen, okay? They commonly will throw in different hormones, just making sure that you understand exactly what they're talking about. Okay, you guys, thank you for watching. That concludes our video for today. If you found this video helpful, please visit. All right, you guys, thank you for watching. That concludes our video for today on hyperplasia and hypertrophy. If you found this video helpful, please visit thehealingpowerofnature.com for more exclusive top-tier study materials. This also includes our complete pathology book that's going to be released that makes passing USMLE Step 1 as easy as humanly possible. Your support really means everything to us. Feel free to also visit our Patreon for top-tier exclusive study content like bonus materials, practice questions, and more. Together, we can make this as easy as possible and keep high-yield content coming your way. Also, don't forget to like, subscribe, and share this video with your fellow future doctors. Thank you very much.